Hello and welcome back to my channel, Java with Ali, and I am Ali, and today we are going to do selection sort. So please like, share and subscribe if you like these videos, and I'll keep making them. This is part of the upper intermediate playlist. If you want to see more, please check out my other playlists. I also have playlists on how to program faster, procrastination hacks, sleep hacks and all sorts. Okay, so, and also kind of a vlog. So today we're going to do selection sort. I have it already typed out. So selection sort is another inefficient but very simple way of sorting an array. So a collection of data. So we have a selection sort is quite interesting because it's inefficient because it takes the smallest, it selects the smallest in an array. So let's say you have an array from 1 to 100 and the smallest number is 4. So let's say 4 is now where like the 100th position is, so the 99th index. And now it will swap it with the very first. So when you swap it then with the first, then it goes through a series of selecting and comparing each and every one thing. So we will take a look through this program and you can see. So the order that I've written this program is quite straightforward because the entry point is always through the main thread. So I've put that at the start. Other people put it at the end after the other methods, but I've put it at the beginning because that's where the other methods are called and it's the entry point of our program, just like a computer enters. So we have here our two imported packages. We have our class encapsulating everything as usual. So we have our class and then our methods, like a layered onion. So this is the outer layer is our class and the inner layers are our methods. So we have here our main, and we have secure random. I've called the new object secure random generated values because that's what it's going to do. And we are going to use part of streams to generate them. So we have here, and our next line on line 9, we have an integer type array called data, and we're going to pass these. So if you read it, and I said this is the very early stages of earlier videos, if you read it the other way, so we're looking at toArray is the method that's called on the data that's here. So we've got toArray that's going to be part of our int stream, returns an array containing the elements of this stream. It's a terminal operation. Here we have our ints, which when I hover over it, it can tell us what it is. So it is java.util.random ints, and it has our long stream size. So the size itself, I've set it to 5 so that we can see clearly 5 numbers. I set it to 1 to start at 1, and 10 is going to be our basically max. So if we have here, yeah, our number, random number bound. So you can see here the bound exclusive of each random value. So you can see that in a second. And that's all done through the secure random. So we have our object dot method, which is going to be our ints, and then our toArray. We print it out so we can see what we have in it. The rest of the program is irrelevant at the moment because all we're doing is printing it out. We're using the toString as part of the collections. So we have our toString here as part of the arrays. So we can see, and this is part of the collections framework. If you're unsure, please check out the collections video. And we pass our data here, and it's going to be printed as a string because we converted to a string. So we have our data, which is our int here. Information is put in here, converted to a string. We're using the collections array object to do it, and then we print it out. Then we call a method called selection sort. So if I hold Control and click, it will bring us to the selection sort. And you can do this with larger programs as well. It's quite nice functionality within a lot of integrated development environments that you can do shortcuts to jump to the methods, especially when you're working with large programs or spaghetti code. But you have tools like Sonar to detect some efficiencies within the code. A lot of industry uses that, and you have other tools as well that can be brought into an organization to check comment density and spaghetti code and things like that. So we have a cyclomatic complexity, it's called. So we have here public static void, selection, sort, and we pass through our data. So our original generated values from 1 to 10, 5 values from 1 to 10. Then what we're going to do first is take a for loop and loop through it. We're not doing enhanced for because we need the counter as well. And obviously we have a -1 because we're looking at the index, not the length. And I repeat this all the time throughout my videos, the length is different to the index. So index starts with 0, length is just the number of elements which we count as normal counting. So we have here our for, which is going to go through initially our data first. So, and it goes through each value, and then we assign the smallest I to the smallest. The next thing we do is we're going to, and this is called index, but you can also call it I because it's within this for as well. So it's kind of complicated with 2 for loops. So this is why we're going to differentiate between it. And this I is going to refer to the outer for loop, as you can see. So I can't call this I because this is still part of the stack. Okay, so when we talk about a variable life cycle, this is what we're talking about because it's within the scope of the outer for loop, and then we have the inner for loop, like an onion. It's got layers. So here we have our index, then we're going to say index plus. So we're going to take our index from our data first and +1, and then we iterate through it. Here is the most important part because we take our data index and we say if it's smaller than the smallest, then index is going to be equal to smallest. Then we call another method called swap. Now, usually, kind of like when you're writing an essay, and this is probably why it's called a programming language, because it's like a language in itself. So when you write an essay, they usually say each paragraph should have one clear idea or topic or function within an essay or within a story. Same with programming. With programming, you have a method should do like one task, one main task, and then you can use other methods to tie into it. So swap is now our helper method. It's a small method, but it gives a clear indication of what it's doing. Here we pass through data, then we pass through our I from our outer for here, because we are still within the for loop when we call these methods. So if you're wondering about last in, first out stack and method calls and things like that, this method is still open. It still hasn't closed its books just yet. So we're calling another method within this method, and we have data, I, and smallest. Another thing to be aware of is that you can have like multiple selection and search types, and it all boils down to 2 things really, is memory and computing, so the time that it takes to process it, so processing time and memory. So they're the two things that it kind of depends on, and they're the two things that will determine what one you use as well. Anyway, that comes to a different topic, so I'll leave it there. That's the simplified version. So we have swap here, which is going to be the most important part for this, because we're swapping in and out. So if I have my 1 to 100, 4 is my smallest, I now swap 4 to the first. So the first being I. Then the second is going to be the smallest. So the second, now the smallest is now going to be swapped to the first. Okay. Then we have our temp. So you're basically swapping around. And I did a couple of weeks ago the Towers of Hanoi example. So this is where if you take like 3 cups and try and swap things between 1 and 2 cups, you need a temporary place to put the thing before you can. So we've got an int temp variable, it's called. And so our temp variable then goes into our second. So we can't just go second to first to second, we have to say temp. Then we have, that's our swap. So our data I and our smallest with our, so store first in temporary. Here we have store the first in the temporary, then replace the first with the second, and then put the temporary in the second. So that's kind of the most easy thing to, if you can visualize it, it's a little bit easier. Then we call another function called print pass, which is here. Oh, what happened there? Print pass, which is here. And we also bring in our data pass and index, which up here is going to be our I plus 1, which we know from our outer for loop is our counter here, plus 1. So, and our smallest as well. So then we just print out after pass and print out our pass. So you can see each time that it passes through. If I had a larger array, it would pass through multiple more times, but we have just an array at the moment. We have, where's our array? We have our array from 1 to 10, and we have 5 numbers in it. So not too bad so far. So there shouldn't be that many passes to swap them in and out. And you can see visually how it's swapped in and out in a second. We have just our initial 4 is going to output the elements to the selected item. Then we have our indication of our swap, which is going to be part of this little star here. Then we finish outputting the array. Then we also have, just for formatting purposes and alignment, and now finally we print out amount of array that's sorted. So, and then we call just a blank empty line. So if I run, then obviously we go back up here. This has now been processed. This method is now finished. Then we go back up here, and then obviously the output then is printed here. So that's how the program would be run and finished. So if I run this now, here we have our 5 elements. So in the first index 0 is 3. So 3 is after our first pass is going to be swapped. So 3 was at the start, which is here. We have 2 1s, which are 2 smallest ones. So 3 is swapped. And you can see where it goes. It goes to the 3rd position. The second time it sees, oh my God, there's another 1. Let's swap that as well with 2. So initially it selects the smallest. So the smallest would be 1. It swaps it with the first here. So 1 is now swapped with 3. Then it selects the smallest again, which is 1, and swaps it with 2, which is here in the original. Then it's going to go again and swap the smallest being 3. And now we have a complete picture, 1, 1, 2, 3, 6. Then we run it again with a larger amount of numbers, let's say 1 to 100. And we'll put in 10 this time. It's inefficient, so it might take some time, yeah. On my computer, can you imagine in an organization and they ask you to do like sort these out and pick the relevant selection sort or whatever relevant algorithm that you need to sort through these, and you pick selection sort, and there are thousands or millions of things that would take so much longer. This is just on my computer at home with 10 items. So this is why we have to be careful. We need good memory and everything else. Good memory, good processing power. So here we have 4 is going to be our smallest. 4 gets passed to the front. There's 4. Done. Next, where's the next smallest? Next one is 6. 6 is my next smallest. Then it gets passed to the second place, which is there already. Great. So then we have, where's our next smallest, which is 14. 14 is our next smallest. Then 14 gets passed. Ta-da! Then where's our next one is 15. 15 gets swapped. That's our next smallest, and so on and so forth. So it keeps going through each as it continues the whole way down through until it's fully sorted. And that's selection sort. So the next one is going to be insertion sort. It's important to remember the big O notation for efficiency when you're looking at these. So for linear search, it's going to be O order n. Order n. I can never remember how to actually say the correct terminology. I've got it written down here though. Let me just check it. Oh, that's our next one. So for efficiency in big O notation, the smallest term drops out and constants are ignored, leaving a big O of O n squared. So that is, or order n squared, that is for selection sort. For the previous searches that we did, so for the efficiency of, let's say, binary search, which I probably didn't mention, is order log n, and for linear it's going to be on, because we can go as many times as we want through it. Order n, it would be said to be called. Okay, that's it. Thanks for watching. If you liked the video, please like, share, and subscribe. And we'll continue so next week with insertion sort, and then we go on to merge sort, and then we have all our sorted stuff, and then we go on to more things. Okay, thanks for watching. Bye.